So in this video, we just want to get an overview of functions. These are things we've talked about previously with functions, but just a nice little summary before we move on and do even more with functions. So for our notation, we're using y equals f of x, where x is telling us about the input for our function, and f is telling us the function that is taken upon x to create our y coordinate. So we input x and the output is y. In terms of dependence, y is dependent on x. So x is independent in that we can choose what we want to put in for x. Sometimes we have limitations, which comes from our domain, but we can plug in different values for x, and y will be dependent upon that value and how it's calculated. Something we talked about before is average rate of change, so AROC, and to find that we're taking a difference in outputs over difference in inputs. In the next video, we'll talk more about how this relates to slope, but for this video, we're going to just use it as looking at the average rate of change of our function from a starting value to an ending value. Okay, so let's try out some things here. So if g of x is 3x plus 1 and we want to find g of 4, then what we're going to do is have 3x plus 1, but instead of x, we're going to replace it with parentheses and our input will be 4. And then we simplify down to 12 plus 1, which is 13. And so we have this expression that g of 4 is equal to 13. What we're also getting out of this is that if we have an x value of 4, our y value would be 13 for this function g of x. Then, if f of x is this negative 2x squared minus 5, if we input a negative 1, so f of negative 1, we're going to go negative 2 times x, and again, we're going to use parentheses, and they're very important in this case because we need to show that the negative is inside of those parentheses. So we'll have a negative 2 multiplying, and then this negative 1 quantity squared would be a positive 1, and minus 5. So negative 2 minus 5 for a negative 7. So f of negative 1 is a negative 7, or if you think of it in terms of a coordinate, negative 1, negative 7. If h of x is 4x squared minus 3, find the average rate of change from x equals negative 2 to x equals 3. So we're going to look at h of 3 minus h of negative 2 all over 3 minus a negative 2. Now we can find those values for h as some side work and then plug them in. In fact, let's do that here, or you could do it all together. You just want to be very careful with how you plug in the values. So let's say off to the side, I wanted to find h of 3. So I'm taking 4 times x squared minus 3, but now my input is a positive 3. So that's a 4 times 9 minus 3, so 36 minus 3 is a 33. So what we can do is take that value we just found, that 33, and replace it where we had h of 3. Then for h of negative 2, we're going to go 4 times negative 2 squared minus 3, which is a 4 times positive 4. So a 16 minus 3, which is 13. And what we could do is take that 13 and plug it in where we had h of negative 2. So going back to my average rate of change formula, we're going to substitute in 33 minus 13, and then we have that over a 3 plus 2. So this will be a 20 over 5, which will simplify down to a 4. So those are some different ways we can use our function notation. Now let's talk about what we can do with graphs. So determining whether or not we have a function, we do the vertical line test. So what we do is we imagine all the possible vertical lines we can draw, and we should only be crossing our function at most once. If there was any spot where we crossed more than once, it would not be a function. But since we're crossing at most once, yes, it passes the vertical line test. Now for one-to-one, what we're looking at, or rather what we're looking for, is if it's possible to have the same y value for two different x values, which is fine for a function, but not okay for a one-to-one function. So with this, we do the horizontal line test. And what should happen is if it's one-to-one, we should be crossing at most once, but we can see some spots here where we're crossing more than once. So what that's showing me is if I plug in about 2.2 or about 3.8, we're getting this same output of positive 2. So with that, it is not one-to-one because it fails the horizontal line test. So we have those two tests to see whether or not we have a function, and then whether or not that function is one-to-one. Finding h of 2, what we're going to do is go to x equals 2, because that's what they're giving us, and we want the y coordinate. So right here we have this coordinate 2, 1. So if I want to know the output at h of 2, the output value is that positive 1 coming from the y coordinate. If we look at h of negative 4, so now what we're doing is changing our x value. So I'm going to negative 4 and then finding the coordinate on my function, which is a negative 4, negative 5. And so for our function notation, what we would do is say h of negative 4 is equal to, and then we grab that y value, which was a negative 5. Now this next case where it's saying solve, what we're being given is the y value, and we want to find the possible x values. So with this one, what I recommend doing is drawing a horizontal line. In this case, we're looking at y equals negative 5. So along negative 5, I'm going to draw a horizontal line, and I want to find all the spots that we intersect with our function. So we have that coordinate that we saw before, the negative 4, negative 5, but we also have 0, negative 5. So with that, solving h of x equals negative 5, I'm going to say x equals, and then negative 4 or 0. So there's two possibilities there. And that right there shows that this is not one-to-one. If it was one-to-one, there could only be one value for x, but that's not happening in this case. Solving h of x equals 3, so we're going to do the same thing, but y equals positive 3. So let's go up here, draw my horizontal line, and what we can see is there's one intersection. So we have the coordinate 3, 3. So we'll say that we can solve this when x is equal to positive 3. Okay, let's get a refresher of domain and range. So domain is the possible x values, range is the possible y values. What we'll do is we'll write these in interval notation. So in terms of x, what I'm doing is I'm looking from left to right and seeing where's my function starting on the left-hand side, and then where's it ending on the right-hand side. So for our function, we're starting at negative 5, but we're not including negative 5. And then we have everything in between here until we get to positive 6, and we can include positive 6, but that's where our x values end for our function. So for domain, we're starting at negative 5, going to positive 6. We're going to use parentheses with negative 5 to show we're not including that endpoint, but at positive 6 we are, so we're going to use a square bracket. Now for range, we do the same thing, but it's thinking in terms of up and down. So we start with our lowest y value, and then we go to our highest y value. So if I kind of think of walking along this y-axis, I have nothing, nothing, until I get to negative 5. And we are defined at negative 5, so I'm going to use a solid circle there. And then my function is defined for all of these y values all the way up to positive 3, including positive 3. So again, we're kind of thinking in terms of horizontal lines here and just where is our function defined. So we're going from negative 5 to positive 3, and we're including both of those endpoints, so we use square brackets. Okay, last question here that I just wanted to add in for another case of average rate of change, which we'll do a lot more in the next video, but just as a little introduction before we get there. If I wanted to find the average rate of change from x equals -1, so we're starting at -1 and then to +2. So what we're going to do is grab both of those points there. So we have the coordinate -1, -3. And we also have the coordinate 2, +1. So if I wanted to find the average rate of change, what I would do is take f of 2 minus, oops, sorry, we're using h here, not f. So h of 2 minus h of -1 over 2 minus a -1. Now our y value at +2 is a +1, so we'll substitute that in. Minus h of -1, which would be that y value of -3, all over 2 plus 1. So let's see, we have a 1 plus 3, which is a +4 over 3. So we're getting an average rate of change of 4/3. And what we're going to talk about in this next video is what we did is we found the slope between those 2 points. And this line that I'm drawing right here is called the secant line. And what we could do is map the slope between those two. So we went up 4, right, went too far. One more time. Up 4 and right 3. And that gets us to our next point. So it's describing the slope between those two coordinates. And we'll talk about that more in the next video.